Hello friends and welcome to our channel Target Jam. Today we will discuss about aromaticity part 2, mainly antiaromaticity, homoaromaticity and ring current. And then as usual we will practice some MCQ series. First we will discuss about aromatic ring current. If a magnetic field is directed perpendicular to the plane of a aromatic system, then a ring current is induced in the delocalized pi electrons of the aromatic ring. See in this figure, this is basically benzene ring and a perpendicular magnetic field is there, and in this case the ring current is generated. And aromatic ring current is an effect observed in aromatic molecules such as benzene, naphthalene, etc. This is a direct consequence of Ampere's law, since the electrons involved are free to circulate within the ring. Now, antiaromaticity, the property by virtue of which a cyclic system containing delocalized 4 and pi electrons become highly destabilized, and this is known as antiaromaticity. And the conditions to be antiaromatics are cyclic, planar, conjugated and 4 and pi electrons. See, the difference between aromaticity and antiaromaticity is basically on the number of pi electrons. For antiaromaticity, the number of pi electrons will be 4 and pi electrons for n equal to 0, 1, 2, 3, etc. See, in this case, the anion generated from the cyclopropene, which will have 4 pi electrons, and this system also cyclic, planar and conjugated. So this is an antiaromatic system, and in this case when the cyclopentadienyl chloride loses its Cl minus, then it forms the cyclopentadienyl cation, which has 4 pi electrons and cyclic, planar and conjugated, so it is also antiaromatic and highly unstable. Now the question is, justify or criticize the resonance of cyclobutadiene, and this is the two resonating form in cyclobutadiene, that is the alternation of the single bond and double bond. The resonance in cyclobutadiene does not occur because in that case the system would become antiaromatic and highly unstable. So to gain stability, it escapes from the antiaromaticity by assuming rectangular planar geometry in which the double bonds becomes localized, so it is non-aromatic. So in case of cyclobutadiene, it has 4 pi electrons, cyclic, planar. Now if it undergo conjugation or resonance, then it will be antiaromatic, but if it prohibits the conjugation, then the single bond will be longer and the double bond will be shorter, and the double bond will be localized with particular carbon-carbon bonds, and then it will behave as a non-aromatic system. Now for square planar cyclobutadiene, that is for antiaromatic system, the electronic distribution will be like this, that is it will have some unpaired electrons, and we know that unpaired electrons are highly unstable. But if it gets the actual rectangular structure, then the electronic distribution will be like this. That means all the electrons are paired, and the non-aromatic system is much more stable than the anti-aromatic system. So CBT has this non-aromatic structure and this pair electrons distribution. Now homoaromaticity. See, this is an example of cyclooctatetraene. When cyclooctatetraene gets protonated, then one of its sp2 carbon converted to the sp3, and in this species 7 sp2 carbon atoms lies on the same plane, and the remaining sp3 carbon will be out of the plane, and now 6 pi electrons will delocalize over 7 sp2 carbon atoms, and in spite of the presence of one intervening sp3 carbon, the 6 pi electrons can form a closed shell, and this system behaves as an aromatic, and this type of aromaticity is known as homoaromaticity. This is another example of homoaromaticity. Here also, in spite of one sp3 carbon atom, the other 3 sp2 carbon atoms forms a closed shell, and that forms the homoaromatic compound. And in this case, in presence of 2 sp3 carbon atom, the closed shell formation occur, and this also behaves as a like aromatic compound, and this type of system is known as bis homoaromatic compound. 2 sp3 carbon, so bis homoaromaticity. Now we are moving to practice set. Question 1. Which of the followings are aromatic in nature? See, there are 4 polyenes. You have to find which one are the aromatics. Option A, 2 only. Option B, 2, 3 and 4. Option C, 2 and 4. Option D, 1, 2, 3 and 4. All are aromatic. Choose the correct option for aromatic compounds, and we are now going to check the answer key. The right option is option D, that is all are aromatic. See, in this case, in the pyrite system, we have to count the peripheral pi electrons, and both the system contain 14 peripheral pi electrons, so they follows the 4n plus 2 pi electron system. So these two are aromatic, and in this compound 1, the inside double bond, this double bond has some double bond character, that means olefinic character, and the other bonds behaves as a aromatic character. And in these two cases, that is 14 aniline and 18 aniline, they are aromatic because they have 4n plus 2 pi 4n plus 2 pi electron system, but having some olefinic character by losing its planarity because of steric interactions of 4 and 6 hydrogen atoms respectively, situated inside the ring. And the resonance energy of 18 aluminine is somewhat higher than 14 aluminine. This is because the size of 18 aluminine is somewhat greater than the 14 aluminine. As the size is more, so the intranuclear interactions among these 6 hydrogen quite less than this 14 aluminine. Now, question 2. Find the correct statement about azulene. Option A, azulene is a non-aromatic and non-polar molecule. Option B, azulene is a non-aromatic but polar molecule. Option C, azulene is an aromatic non-polar molecule. Option D, azulene is an aromatic polar compound. Choose the correct statement about azulene. We are now going to check the answer key, and the right option is option D, that is azulene is an aromatic polar compound. See, azulene easily forms this dipolar form to get its aromaticity, and the charged canonical forms will be more stable because in this structure each ring separately becomes aromatic with 6 pi electrons, so it will be major contributor, and so azulene is polar and it has dipole moment mu equal to approximately 1 dpi. So azulene is an aromatic polar compound. Question 3. Find the correct statement among the following. See the resonance structure of O1 and O1A and 2 and 2A. Options are option A, O1A is more stable than 2A. Option B, 2A is more stable than 1A. Option C, 1A is aromatic but 2A is non-aromatic. Option D, both are aromatic and equally stable. Choose the correct statement about these azulene derivatives. we are now going to check the answer key, and the right option is option A, that is 1A is more stable than 2A. See, in this case, say in compound 1, that due to getting the aromatic character, 1A is the main contributing form, and in case of 1A, the 5-member ring, it has negative charge on this, and Cn shows the minus R effect, so it also stabilizes the negative charge on this 5-member ring, and the 7-member ring contain positive charge, and the OMe group shows plus R effect, so it also stabilizes the cation adjacent to it. But in case of 2A, this is completely reverse, that is OMe, which is destabilize the negative charge in the 5-member ring, and in the another side, the Cn, it shows minus R effect and destabilize the cation. So compound 1A is more stable than the 2A. Question 4. Choose the correct aromatic molecules among the following. See the structure of these 4 compounds and find them which are the aromatic molecules. Option A, 1, 2 and 3 are aromatic. Option B, 2, 3 and 4 are aromatic. Option C, 1, 3 and 4 are aromatic. Option D, 1, 2 and 4 are aromatic. Choose the correct option. We are now going to check the answer key, and the right option is option D, that is 1, 2 and 4 are aromatic. See, in compound 1, this easily converted to this dipolar form, and this 7-member ring has 6 pi electrons, so it is aromatic. Similarly, compound 2 also aromatic. But in case of compound 3, there is one sp3 carbon adjacent to OH, so it is non-aromatic as there is no resonance. But in case of compound 4, there also charge separation occur and form this aromatic form. So compound 1, 2 and 4 are aromatic. Question 5. Find the correct order of stabilization among the following canonical forms of naphthalene. See, there are 3 canonical forms of naphthalene. You have to find the stability order among these 3 forms. Option A, 1 equal to 2 equal to 3. Option B, 1 greater than 2 greater than 3. Option C, 1 equal to 2 greater than 3. Option D, 1 greater than 2 equal to 3. Choose the correct stability order among these 3 canonical forms. We are now going to check the answer key, and the right option is option D, that is 1 greater than 2 equal to 3. See, we have to first check the number of benzenoid and quinonoid form in each canonical form. Basically, benzenoid form means like benzene, and in quinonoid form means like quinone. The arrangement of double bond is like this quinone. So in compound 1, there are 2 benzenoid forms. In compound 2 and 3, there are 1 benzenoid and 1 quinonoid forms. Now, Fry's rule says that for condensed ring aromatic system, the canonical forms with more number of benzenoid ring will be more stable. So compound 1 is the most stable, and compound 2 and 3 are equally stable. Question 6. Select the correct statement about the resonance of cycloocta tetraene, that is COT. Option A, resonance occurs and COT is aromatic. Option B, resonance occurs and COT is antiaromatic. Option C, resonance prohibited and COT is non-aromatic. Option D, resonance occurs and COT is homoaromatic. Choose the correct statement about the COT, cycloocta tetraene. we are now going to check the answer key, and the right option is option C, that is resonance prohibited, and CO2 is non-aromatic. See, CO2 has 8 electrons, so it follows the 4n pi electron system, and its electron distribution will be like this, that is it will have unpaired electrons which will be highly unstable, that is it is anti-aromatic structure. But in X-ray structure says that it has star shaped structure, so the electron distribution will be like this, that is paired, and it behaves as a non-aromatic compound. So the right option is resonance prohibited, and CO2 is non-aromatic. Question 7. Find the correct statement if all the following compounds are planar. There are 4 compounds: pentylene, biphenyline, 12-annuline, and hexadehydro-12-annuline. Consider that all these 4 compounds are planar. Then find the correct statement. Option A, one is aromatic and others antiaromatic. Option B, two is aromatic and others are antiaromatic. Option C, 4 is aromatic and others are antiaromatic. Option D, all are antiaromatic. Find the correct statement, and we are now going to check the answer key. The right option is option D, that is all are antiaromatic. See, in this case all the molecules follows the 4n pi electron system, and in case of compound 4 we have to count only the 12 peripheral electrons, because other 1 2 3 4 5 6 6 into 2, that is in case of triple bond we have to consider only the one pi bond which will participate in the resonance, other pi bond will not participate in the resonance. So these all are anti-aromatic in nature. Question 8. Which of the following are aromatic? Pyridine, beryllium, and pyran. Option A, 1 only. Option B, 2 and 3. Option C, 1 and 2. Option D, all of the above. Choose the correct statement, and we are now going to check the answer key, and the right option is option C, that is 1 and 2 are aromatic. See, pyridine and beryllium, these two both have 6 pi electrons, so they are cyclic, planar and conjugated, so they are aromatic. But in case of pyran there is one sp3 carbon, so it is non-aromatic. Question 9. Arrange the molecules according to the decreasing order of acidity. There are 4 molecules, 1 2 3 and 4. You have to find the correct order of acidity. Option A, 1 greater than 2 greater than 3 greater than 4. Option B, 1 greater than 4 greater than 3 greater than 2. Option C, 4 greater than 1 greater than 3 greater than 2. Option D, 4 greater than 3 greater than 1 greater than 2. Choose the correct order of acidity, and we are now going to check the answer key. The right option is option A, that is 1 greater than 2 greater than 3 greater than 4. See, in these 4 molecules each of these has one 5-member ring which has 2 pi bonds, and when they loses one proton the 5-member ring gets aromatized. Now in case of compound 1 and 2, this is completely non-aromatic, but when it loses proton then they convert it to the aromatic compound. So by aromatization they gets stabilized. Now between compound 1 and 2, 1 has 4 CF3 groups which are electron withdrawing group. So when it forms the anion, and this anion stabilized by these electron withdrawing groups, and compound 1 behaves strong acid, even much more stronger than the nitric acid, and then compound 2. Now in case of compound 3 and 4, there are already partially aromatic because aromatic benzene rings are there. And in compound 3, its pKa is 20, that is weakly acidic. And due to the annihilation of 6-membered rings, the electrons are less available for aromaticity gaining of 5-membered ring. And in case of fluorine, its pKa is 23, that is it is even less acidic. And due to annihilation for 2 6-membered rings, the electrons are even less available for aromaticity gaining of 5-membered rings. So the order is 1 greater than 2 greater than 3 greater than 4. Question 10. Find the correct statement among the following: pentylene, azulene and naphthalene. These three compounds are there. You have to find the correct statement. Option A, all are antiaromatic compound. Option B, one is antiaromatic but 2 and 3 are aromatic. Option C, 1 and 3 are antiaromatic but 2 is aromatic. Option D, 1 antiaromatic, 2 aromatic and 3 non-aromatic. Choose the correct statement and we are now going to check the answer key. The right option is option D, that is 1 is antiaromatic, 2 is, that means azulene is aromatic and naphthalene is non-aromatic. Naphthalene is non-aromatic in spite of the 12 pi electron system because it's get non-planar structure. And in case of pentylene, there are 8 pi electrons and it is very small rings are there, so it is remain in planar, so it is non-aromatic. And in case of azulene, we have seen in previous that it forms the dipolar form, that is cation and anion, so it is aromatic system. And total 10 pi electrons are there, that is it follows the Huckel's rule for 4n plus 2 pi electron system. And when it gets the dipolar form, then H of the ring gets the 6 pi electron system. And in case of naphthalene, there are 6 pi bond, that means 12 pi electron, that is 4n pi electron system. So it should be non-aromatic, it should be anti-aromatic, but as it gets the non-planar structure, so it is non-aromatic. Now calculate and evaluate your performance, and in our next tutorial topic we will discuss about aromaticity part 3. Now thank you for being with us. Thank you.